So, like you might have already heard about IP address. It is similar like every house have a unique house address, right? Similarly, every computer, every server will have a IP address. Using that IP address only, we can able to connect to that server. So, as in the previous demo, I was giving an example about Ansible tool, right? Ansible tool do what? It deploys the softwares, right? So that tool requires IP addresses. So, what is an IP address? IP stands for Internet Protocol. An IP address is a unique address that identifies a device on the internet or a local network, which is a set of rules governing the formats of data sent via the internet or local network. So, whenever you're suppose, for example, when for example you typed amazon.in, right? So you are typing a URL actually, but actually we have a server running somewhere in the somewhere in the somewhere on in different locations actually. So domain name server, we say that domain name server. Okay, so or in short we say DNS. So this DNS will contain what? A list actually. It contains a list of IP addresses. For example, you typed amazon.in, then for that associated URL there will be a IP address for it, something, some IP address for that. So as a end user, you like you and me, common people don't know what is IP address. So for them they use the URL actually. When they type URL, then automatically when you type URL, this URL and press enter key, then automatically the DNS will resolve that, and it will convert that URL to a IP address. And this IP address will be associated, this IP address will be associated to a server, server, right? And this server is running somewhere in a data center, right? Yes or no? So this is what we discussed from the beginning. Server is very important term we use many times, and this server is running somewhere in a data center. Okay, this way it will be resolved. So we are all using URLs, but every URL will have a associated IP address, that you should understand. So without IP address, we cannot connect to a server. There are types of IP addresses. There are various classifications of IP addresses, and each category further contains some types. One is private IP address, another is public IP address. In public IP, again we have dynamic IP addresses and static IP address. So this dynamic address always changes. So for example, uh, in real time, what we do while we working on the cloud, normally we give public IP to the developers. So developers always connect to the servers using to the public IP, and that too they use the dynamic IP. So, but if the server stopped, then the dynamic IP will change and a new IP will come. Okay, a new IP address will be come. So actually for that we have another server called DHCP. We have like DNS, we have another server called DHCP. Okay, some it's called dynamic host control protocol. Okay, so this one always, this will take care of giving dynamically, it will create dynamically a new IP address, new public IP address. And when you stop the server, this dynamic this DHCP server do what? It will take that previously given public IP address, and when you start the server again, then this will again give a new IP address. That means the public IP will always change. It's a dynamic, it always change. When you stop and start, the public IP will not be same, it will change. That we see practically maybe in coming 1 or 2 days when we start practicals. At the time I show you that, so how the then IP will change. And then we have static IP address. It's nothing but in our cloud we call it as elastic IP address. So normally in real time we give elastic IP address, even though it's a public IP, it will not changed, it will be same like that, it will not change even you stop and start. So normally developers will use elastic IP address. We will see these all things practically. And private IP address. So uh, for example, amazon.in you typed, and you got a web page, main web page you got it. So so internally at the back end what happened, you are connected to a server, you are connected to a server. So that server having a public IP, that server having a public IP, because it having public IP, anyone can connect to it, name itself saying public IP. So public means anybody can access it. So when you say amazon.in and this is IP, this IP comes under public IP. If it is private, no, then you cannot connect to it, then you cannot connect to it. Then why we require private IP? See, when amazon.in, when you typed it, then what you will do normally, you do, you will select a mobile, select a mobile model, right? When you select a mobile model, and one more thing, I want to give, if you are not using that, if anybody uh, using everyone option, then you can shift to hide everyone. That way you can see full screen. Click on hide everyone option. So domain. So when you select a mobile model, then the model details, the browser, the application, the Amazon application will not have. Actually, that application yesterday I shown you, right? It has to connect to a database. It has to connect to a database. So the database only accessible to the Amazon application. That means the database also will be running in another. It also will running in another server. So your application will be running here, and your database will be running in another server. So here this is your IP, your application, Amazon application, and your database. And this application can be accessed by anyone from the cloud, from the internet. So that is the reason this application will contain a public IP. So that is the reason every server will have a public IP where the application is running. For example, if you say 23.3 dot for 33.1, suppose this is, assume this is a public IP. So a person from his browser he can connect to it because it is a public IP. But this person want to view mobile information. This application will not have all products information. It end of the day it has to go to a database again. It has to connect to another server. In this server, database is running. This application will ask details about that model details. The database contains all the information of every product. So database will immediately give that information back to this application. Then the application will send that information to the browser. So because this ambition internally communicates with this server having, again every server should have a IP address, right? Otherwise they cannot communicate, right? So here it also will have a address, some 126 dot 34 dot some IP address it will also have, but it is a private, it having a private IP. So we cannot connect directly from the browser. We cannot connect to database. Never. It will be, if you are able to connect it, then it will be a security issue. So database contains a lot of information. That information should not be corrupted by anyone. That is the reason always these servers having private IP. So this, whenever a server having private IP, those servers you cannot access them. But the servers having public IP, those you can access. So but these private servers can be accessible internally by this application. It can connect to the database. Hope you understand here. So that is about types of IP addresses. We will do it practically. We will see practically all these things. And what is subnet? A subnet or a subnetwork is a smaller network inside a larger network. So the large network is subdivided into multiple subnets, and each subnet will contain multiple servers. So for example, here in the screen, see all the private servers you can put inside a, subnet. This you can think at a subnet. This one subnet and this another subnet. They are two different subnets. And this subnet, under this subnet, there will be multiple servers are running. In subnet also we have two concepts: public subnet and private subnet. By this, what we do, by this, if the public subnet will have multiple servers, not only one, it can contain 40 to 50 servers, but they all grouped under public subnet. And all the all the servers which are not accessible to through internet are all kept under the private subnet. By this way, we on the subnet level we can give some what do you call, some we can apply some security rules, so that we can restrict so that nobody can connect to them. On the subnet level we can give some security rules, so that we can restrict. And whereas public subnet, which are accessible through the internet, those servers we can bring into this public subnet. So when a rule applied on the subnet level, that rule will be applied to all the servers inside this 40 machines. For example, it having 40 servers, then the rule applies to all those 40 servers. Similarly with private subnet. So when we start working on virtual private cloud, we will deep dive, we will understand all these things. Virtual private cloud. So VPC. So when we work on VPC, at the time I will go into deep and I'll explain all this again. And another device called switch device. So a switch is a device in a computer network that connects other devices together. Multiple data cables are plugged into a switch to enable communication between different networked devices. So it's same like networking, but if you connected the devices, all other devices like printer, laptops or desktops to the same device, then they can communicate among them. It's a switch device. Now, like now, in real time we will be staying in different locations in particular area, and every area will have some different colonies, right? So every colony will have different house number series. Similarly, here also we have the same similar concept. So normally, if you see here, there is a IP address with series of 10.0.0.0, and on the right side we have another series called 20.0.0.0. So both are different series. This series starts from 20 and this series starts from 10. So the servers which are having under this series only they can communicate, but the servers which are under this series, they only communicate among them, but they cannot communicate with the servers which are having under the series of 10. So they cannot communicate among them because they both having different series. So when you want to communicate among them as well, then we have to use a device called gateway. So this is a device which will allow such a way that even though they are having different IP address series, they can communicate among them. This way a big network can be made. So this is another concept you should remember. Gateway is a concept. And comes firewall, like we have on our laptops we have firewalls, right? Similar one. Firewalls are network security systems that prevent unauthorized access to a network. It can be a hardware or software unit that filters the incoming and outgoing traffic within the network, right? So everyone having our own firewalls, right? Windows having its own firewall. Similarly, the firewall allows good traffic and bad traffic, it controls it, right? So similarly on the cloud also, in place of firewall we have a new terminology called security groups. So there we use a new term called security groups. So using security group we can control, same as firewall. So we will see how to use security group, and how can apply various what do you call, rules on it on the server. And about replication, these things I will explain in another slide, but in short here I will try to explain. Replication is a technology for copying and distributing data and database objects from one database to another, and then synchronizing between databases to maintain consistency and integrity of the data. In most cases, replication is a process of reproducing the data at the desired targets. The thing is that, for example, if you take Infosys or any company, So Infosys having a data center in Hyderabad, also in Chennai, Mumbai, in various big cities. So normally what happens is that, uh, if I'm not talking about cloud actually, but in real time what happens, suppose we are working in Hyderabad location for Infosys, and we saw a lot of employees, they are working, and every day they store their data on the servers. On the servers they will push their data from their local machine to data center, to the servers which are running in the data center, right? Every day they save their data into the server, those servers running in the data center. Why they do? Because the laptops which they are using, there could be chance of hardware crash or any problem may happen on their local machine. So to avoid such situations, what they do, they always end of the day they move their whatever data they are having on their laptop, personal on the company given laptop, that from there they will connect, always they connect it to the servers. Actually they always work by connecting to the servers. They will save the data on the servers, so that if anything happens they can retrieve it. But even data centers also could have a problem. For example, if you take Chennai example recently having flood issues. So when floods are occurred at the time, there could be a good chance of not having internet, that there could be a good chance of not having network internet, right? So there could be electricity problem, but networking is a main issue. In that scenario, then assume the Infosys employees who are in Chennai, they cannot access the data center, right? So for that reason, the administrators who are in the Chennai data center, what they will do, they always move the data from Chennai data center to Hyderabad data center, Mumbai data center, Thiruvananthapuram data center, different to the Infosys data centers. They have, wherever they have to there, they move a copy there, and they move a copy, and always they synchronize, they always move the data continuously synchronously. That means if something in Chennai data center nothing has happened fortunately, and still they are moving the data every day, the administrators will move the data to various data centers in various locations. Now assume suddenly some floods have occurred in Chennai. Then no, then employees, when Chennai employees, when trying to fetch the data, when they try to get the data, because Chennai data center is not in operation, then automatically the request will be diverted to either Hyderabad or Bangalore or Mumbai region. Automatically to that location, the traffic, the request will be diverted without their, uh, they will not know, the employees will not know that these are things are happening at the back end. So without knowing, they will be diverted to different locations, and they can get the data on their laptops. So this is very common scenario, and normally these are done by administrators in most of the companies. But whereas in Amazon cloud or any cloud, these things are automatically happen. These things are automatically happen with the help of a software. They will take care everything without involvement of any administrator. So they will always keep replicas in various locations. So here in the screen, I'm saying here primary region, secondary region. But region, what is region? Region, in it's a word we use in terms of cloud. We use the term region. Region is nothing but a city name, a city location. When you say Hyderabad location, it is a region. Mumbai location, it is another region. So in cloud terminology, we use a word called region. So these region things we will talk another 10 minutes in detail in another slide. One moment please. One please. Now let's try to understand in more elaborately about region and availability zones. So region, as I introduced, this term is used in mostly in clouds. So region is nothing but a city, you can say Hyderabad is the region, like that. Then what is availability zone? It is nothing but the data center. Instead of using the name data center, in the cloud environment we use, instead of data center we use a name called availability zone. And here we are saying availability zones, right? Why? Because uh, there is a rule among cloud providers. What is the rule? Where in every region they should have minimum 2 data centers. If you take Infosys for example, if it is in Hyderabad, but in Hyderabad it having only one data center, they don't have any rule. They are private, they can manage with one data center, that is fine. But Amazon or any cloud, Azure or Google Cloud, they have their own rules, like no, in every region they will have two data centers, and these data centers are called as availability zone, right? And these data centers are not very close. They will be they will maintain a distance of 100 kilometers, minimum 100 kilometers to distance they maintain. So in the same region there will be two data centers, but minimum with a minimum distance of 100 kilometers. Why? If they both are in the same place, then no, if something happens at that location, then both data centers will not work, right? That is the reason, even though they are having two data centers, they will maintain a good distance. So that is about availability zone. Let's try to understand about region. Region means geographic locations across the world. So these regions across the world. So there are total 33 regions and 105 availability zones. So as of January 2024, so this number will constantly, it will grow. It continuously grow. So as of now, we have 33 regions. 33 regions means 33 metro cities like Tokyo, Hyderabad, Mumbai. Okay, many places, whole world, in the complete world, in different locations, they have 33 regions, cities. They have data centers, and each data center they have minimum two, right? And in some cities, in some regions, even they have six data centers as well. Six. So that is the reason the count is 105 data centers here, or 105 availability zones. Every region is consists of two or more cluster of data centers, which are called availability zones. We can choose any region to deploy the workloads on AWS. Workloads means whatever the developers develop the code, right? That application we call it as a workload. Not only the application, it could be a database also, right? So that is the reason, in short, if instead of saying application database, instead of that, in short we say workloads. So we can choose any region to deploy the workload. So as a DevOps engineers, what we do, we deploy the various applications, right? So we use mostly for deployment, which tool we use? Ansible tool we use. So using Ansible tool, we can deploy the workloads in any region, anywhere in the world. But again, where to deploy everything, we'll get all the information from the development team. Accordingly, we can do the deployments. We can't. Anyway, we won't take any own decisions, right? Everything will be every detail will be provided. Basing on that, accordingly, we work. Every data center, or AZs in short, we also say AZs, are availability zone, and AWS region is interconnected via a purpose built, highly available, and low latency private global network infrastructure. They are having their own global internet global private network infrastructure. The network is built on a global, fully redundant, and parallel 100 GB metro fiber network that is linked via transoceanic cables across the Atlantic, Pacific, and Indian Oceans, as well as Mediterranean, Red Sea, and South China Seas. So, as we discussed in previous session about WAN, right? Wide area networks. So these are all comes under wide area network. So these fiber networks are laid out along the countries and even continents. So these cables are laid under the oceans as well. So they invest a lot of money for this networking. Now every region has a name and a corresponding code. For example, there is a region called North Virginia. It having a code called US-East-1. This is the code for North Virginia. And we have another region called Mumbai. It is having code called AP-South-1. Like this, the codes will be there for every region. Singapore, Sydney. So for every region, they will have a code, a name like this. And we no need to remember these codes. Everything available on the Amazon website. I will show you that once we have the account created. And these are the different locations in the world. In different locations, these are the orange color what you are seeing here are the different regions, various regions. So why so many regions? Why we require so many regions? Lower latency access to applications. Lower latency means whenever you are trying to access any website, if that website immediately shown up, then we say that it's very fast, right? So because if it is very fast, or we can say it having very low latency. That means the time accessing that website in, is we can access it in very less time. That is the less time we say, no, that is nothing but lower latency. So why so many regions? One reason is lower latency access to applications. That means suppose you deployed you created the company Wipro developed application, for example a Germany client. Then after application is completed, then the application you should deploy into a server, right? Definitely you have to run into in a server, right? So who are non-IT, you should understand that whenever you using your laptop or desktop, you download something, right? When you download on it on your machine, you won't download it, right? And after downloading, what you will do, you double click on it, and it will run. So then you say application is running, right? Similarly, when the developers develop their code, the code will be converted to a binary file, the same file normal which you download from internet, right? That is also a binary file. The developers develop the code, right? That also converted to a binary file, and this binary file should be running, right? So as you double click yourself, the same thing has to be done with the DevOps engineers. What they do, they will move that binary file to a server where that has to be started, or that has to be deployed, or that has to be installed. Various terminologies there: deployment, installation, running the applications, executing the applications. There are different names. So all meaning is same: the application should be running. That's all, simple. You can't keep the binary file like that. Unless you start it, you can't use it, right? So such applications, suppose we got an application developed by some developers in India, and the client is from Germany, and the application is ready now. Then the application is in binary format. Now it has to be started. Then if you start that application, where you have to start? In a server, right? You have to execute in a server. But which server? The details will be provided by the client. The client will provide the server IP, so that you can deploy there. That is fine. Then for example, that application has to be accessed by public in Germany, for example. But the Germany people, will we give IP address? No, right? So the client will do what? He will create a URL for it. He will create a URL, and that URL he will give to consumers, public. Then the public will access that URL, and when access the URL, then automatically they will be connected to that server where our application application has been installed. So the URL is connecting to our server indirectly, and the server IP is given by the client to us. He will mention us, once your application is ready, deploy it in this server, and rest he will take care, the IP, the URL, everything he will take care. But the deployment, where to deploy, that details we require as a DevOps engineer, we require, right? So that means I'm telling about for non-IT people. So what I'm trying to say is that definitely we require a server to deploy the application. Without server, the application cannot be deployed. A server should be there. And this server, if you deploy, and one thing you should take care, that server should not be in Hyderabad Indian location, right? That should be in Germany location. Why? If it is in Hyderabad location, then public who are in accessing, who are accessing, who are in Germany. But from Germany to connect to through internet to Hyderabad data center, there will be some higher latency. They will take some time to see the output on the screen. That is the reason we have many regions. One region also there in Germany. So our developers will be asked to deploy the application in Germany's Amazon data center. Amazon also have a location in Germany. So in that location, they will give IP address, and they also give the region name, and everything. They will give the details. We have to connect to that. How we connect? Again, Amazon cloud provides everything to you. We can connect to it easily with click of a buttons. We can connect to it, and we can deploy our application there simply. Everything happens online. That we will see. That is the reason we should have many regions. Assume Amazon does not have a region on Germany, then the Germany client may go to another data cloud provider, something like Google Cloud. Maybe Google Cloud may be providing a data center in Germany. Then they will go to Google Cloud. That is the reason, because there is a lot of competition among the cloud providers. So all the cloud providers, they make sure that they should have a data center in every main regions. And regulatory companies, the same thing. Regulatory companies, the Germany people, the Germany government will not allow to deploy the application on any other country other than the Germany. Why? Because the application may contain the Germany people's data. That there could be some problems, regulatory problems. That is the reason we have to deploy the application in the same country who are using it. And disaster recovery, far dr. So far dr means disaster recovery. So this time it is region to region disaster recovery. That means, suppose here in Russia and Ukraine war is happening. Suppose Ukraine having some data centers over there, for example, and that data centers having some network issue because of this war, for example. Then automatically Amazon cloud will take care such that all the data which is there on the Ukraine data center will be moved to the nearest region, to Ukraine, so that the end user who are trying to access data, they will be diverted to the new region instead of to Ukraine region. So these all things required to be maintained, but no, everything they will take care. And additional considerations, global applications and cost benefits, right? So global applications, so maybe our application is a good demand, so this that application want to be accessible by many people throughout the world. Then you can consider that application, web application, as a global application. For example, if you take amazon.com, amazon.com is available globally. So you can book order, and you can book a order, and suppose you have a family members in US, somewhere in the US, you can send them the products whatever you can buy in India, and you can send them, you can give the address of US people, your family members address, right? So such applications considered as a global applications. That means if that application only deployed on US data center, then again there could be a lower latency, right? That is the reason the same application will be deployed in US data centers as well in various countries data centers. The same application redeployed in multiple locations, multiple regions. That is one example of amazon.com. There could be multiple applications which are accessible throughout the world. And availability zones, every region consists of two or more cluster of data centers. As I told you, every region should have minimum two or more cluster of data centers. When there are more than one and they are interconnected, then we call it as a cluster. Cluster is nothing but something, two objects, they are interconnected. Anything, that could be anything. Here in our case it is data centers. That is two buildings. These two buildings are interconnected, and we call it as a cluster. And suppose two networks, two servers connected together, we can call it as a cluster. In this cluster we have two servers connected, that way we can say two or more. All right, every region consists of two or more clusters of data centers called availability zones. We call them as availability zone. And every availability zone has a corresponding code which consists of region code followed by alphabets. So for example, Mumbai region has three availability zones. Mumbai region code is this one, AP South one, as we know already, and it contains three data centers. Now, first data center is we called as availability zone 1. We won't call data center, we call it as availability zone 1. What is ID? Just add the region name with hyphen, no, just add a alphabet A, that's all. Up to AP South 1 is the region name, just add a alphabet over there. And zone 2 is B and zone 3 is C. Similarly, if you take another region called North Virginia, it having 6 zones. Then the alphabets will continue. A, B, C, D, E, F. Up to F, the regions, the zones will be separated, having their unique IDs. That we will see from tomorrow. We will see once we have accounts created. From tomorrow, I will show you all these things. One, we will log into Amazon Cloud. So the same thing. So these are the data centers, or availability zones in multiple regions. So this, and again these data centers are interconnected through low latency fiber. So these all data centers are interconnected. So what AZ means to you? What availability zone means to you? So you are sitting somewhere, and this is your local machine, your local laptop, and you are connected to Mumbai region, and Mumbai region having three data centers or three availability zones: AZ1, AZ2, AZ3, three different zones. And you have created a server, for example, on the cloud you have created a server. That server can be created anywhere in the Mumbai region. First thing is that you have to select which region you want to create the server. Assume you have selected Mumbai region. Then after that, what request you will give? I want a server with Windows OS in that. Everything you can select on the Amazon cloud. I will show you that tomorrow. You can give all the details. Once you submit, then immediately within few seconds, a server will be created. Where anywhere, any of the three data centers, it can be created. There is also an option like you can select I want to create only in AZ1 or AZ2 or AZ3. You can do that as well, but it is not mandatory. It's not mandatory, right? But some situations will arise when we have to select a particular region. Such situations I will explain practically when you are working. But as of now, try to understand. So on your local machine, you submitted an order that I want a server. Now the server is created somewhere on the cloud, and you can access it through the internet. Through the internet, you can access it, and you can connect it remotely. And once you connect it to it remotely, you can install softwares on it using Ansible tool. You can install any software on it, and you can start working on it. Why multiple ACs? Application high availability. So if there are more data centers, then your application can be deployed on multiple zones, multiple data centers. See, here is our application, and you can have your application, all same application you can execute on other data center as well if you want, or even other region as well, no problem. But you have to pay accordingly. The rent has to be paid accordingly. As many servers you have, those many, that much rent you have to pay. but but that is very low. But if you have your application running on only one server, and if the server crashes, then the customer cannot access your application, right? So for that reason, either you can have multiple servers on each data center, or you can have same what you call application running on different regions as well. So application high availability. If you deploy your application on multiple zones, then your application will be highly available. That means if one server is crashed, another server will be there automatically serve you. Servers and dash database can be launched across the edges. Synchronous replication is possible with latency less than 10 milliseconds. That means you will have duplicate servers, duplicate applications and database running on different data centers, right? And the database, if you change on one data center, then the database also having on another data center as well, right? So again, the data whatever you changed on one data center will automatically replicated on another data center, another into another database which is running in another data center. I will show you in the picture in a moment this scenario. Fault tolerance, as I told you, if server crashes, then then you can manage, like as your application is running in another data center, near data center. So regions, we have multiple regions, we call it as far DR sites, but AZs we call as near DR sites. Why near? Because these data centers are just 100 kilometers far away, whereas regions will far away from even hundreds of kilometers far away, right? So these are called near DR site. Why? If the data center itself AZ1 itself crashed, having some network issues, then these two data centers are still available. And if your application is running in any of these data center, then no problem, end users can access your application because your application is running in any one of the another these data centers. So to avoid such situations, your application should run even on multiple data centers. Note that all AZs are functionality same for end users. It does not really matters which AZ you are using to deploy your single instance. However, for high availability of the application, you should launch multiple instances in different AZs, right? So your application should available to multiple people, even one server is crashed in particular one particular data center, no problem, automatically cloud will take care. It will identify that okay, this server is not working in my data center, because cloud is maintaining, right? Cloud is maintaining. So cloud immediately understands, okay, in my cloud this server has been crashed. Then immediately the cloud will take care. He will automatically divert this person to another data center. He will take care, we don't need to worry. The same thing we'll see here. Suppose if you take the sample architecture, here is a region, right? It is zone 1 and zone 2. Here is Amazon application running in this server. It is here in this Amazon application is running, and this application requires data, right? That data is available in the another server, and in that another server, our database is running. So these two will communicate. This having private IP, this having public IP. These people can connect only to this application, and this data, whatever data we changed is changed by the developers, will automatically replicate it to this database. Or these people may be doing some selecting some products, and maybe they may check out, they will check out, they will check out, whatever they do, the activities, everything will be recorded in the database, and everything the same at the same time will be replicated the same information to another database. And while they're doing the payment, suppose the servers crash down, no problem, all the details are uploaded to another database, and automatically these people will connect it to another database. You see, if this crashed, then they will be connected to another zone, and all the information already moved to another database instantly. So the checkout process will not disturb. They will not come to know that they are working on other zone. They don't know that everything will be, whatever they're doing, everything will be go smoothly, without any without any disturbance. So these all things maintained by the cloud itself. So we'll discuss in detail further in practically. These are the theory I want to cover as of now. So I covered most of the theory now. So next we have to move to creating an account. So let's try to create an account. So anybody want to share your screen so that others